Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future. Our natural world is in crisis. Buildings emit 40% of carbon globally. We need solutions now. Join the conversation today. Welcome back to Building the Future, Green Building in the New Millennium, the podcast where Ginger and I flip the script on traditional building design and construction and bring you brand new ideas, technologies, and an emerging new approach to development that says it's possible to design healthy, high-performing buildings and cities without breaking the bank. Today, we're going to continue our discussion of what high performance means with respect to both building retrofits and new construction. And we started the conversation last week by going over ways to reduce, reuse, and recycle water. And today we will seamlessly transition over to reduction and reuse of energy. Welcome, Ginger, to the Sustainability Table. Can you tell our listeners a little bit more about what to expect from today's energy episode?
Well, thank you, Ian. Glad to be here. And a big thank you to all our motivated listeners out there joining us today to explore something I'm super interested in, everything energy. So we appreciate you and value your feedback. So where does it come from? What is it used for? And how can we use less and minimize the use of fossil fuels in the built environment? That is the essential question. So we'll be discussing alternatives to fossil fuels, and we'll dig in a little deeper to the term energy efficiency, a hot topic in today's built environment. Also, appliances, building efficiency standards, integrated systems, automation, and technology, and what we in the biz call prop tech. So that's going to be really super exciting. But first, Ian, why don't you kick things off and talk about the principle of net zero energy and why it's so important, yet often very, very confusing for the average building owner.
Yeah. A net zero building, as we actually defined in an earlier episode on sustainable architecture, is basically a building that produces as much or more energy as it consumes over the course of a year. Simple, right?
Sounds simple, but I doubt that it is. I'm sure you'll tell us.
Yeah, the first reference I actually found to the term in the US was a paper put out by the US DOE, Department of Energy, in 2006, discussing the various sub-definitions of zero energy buildings. And that study took a look at 7 high-performing buildings in the US at the time and what it would take to make them net zero energy. And guess what, Ginger? 2 of them were all electric. That's not exactly the perfect solution for every building, but it is a fantastic way to lower emissions that's really gaining traction across the US and the rest of the world.
Absolutely. And all electric, the concept we here at Sustainable Homes of the Future are really trying to bring home and to that concept and bring it to the table so that our listeners and our clients can really get a vision of the true future of sustainability.
It is the future indeed. There are way too many acronyms when it comes to net zero. Just to name a few here: NZE, ZEB, ZEH, NZB, little n, big ZEB, and about 4 different sub-definitions. Don't worry, that's all we're going to say about that. I'll put the link to the paper in the show notes if you really want to go down that rabbit hole. It wasn't actually until 10 years later that the DOE came out with an official agreed upon definition of what a zero energy building actually is. And the average builder still isn't really all that familiar with the term because of all the confusion around how exactly we're supposed to measure zero.
And now the industry has added several additional terms like net zero water, net zero waste, net zero carbon. So those concepts are really out there. A lot more about zero carbon in our next episode, by the way, and we're going to be talking all about carbon emissions and how to eliminate those in the building environment.
We've spent a lot of time discussing strategies to make buildings healthier and also help mitigate climate change. But, it's worth noting that a year after the release of that 2006 paper by the DOE, President George W. Bush actually signed into law legislation to research a federal path toward net zero so our country wouldn't be so dependent on foreign oil.
So there's more to it than just keeping the environment clean. The environment clean, national security.
Yeah. Yeah, we're talking about sustainability here, and true sustainability has to take into account both energy efficiency and also energy sufficiency. We're working toward a future that works for everybody, and we don't want to be forced to buy nuclear power from Russia or China 20 years from now because we as a country didn't have the foresight to focus on our own sustainable energy, which brings us to renewables. You want to take this, Ginger?
Sure. Renewable or clean energy is just what it sounds like, alternative energy sources that don't actively emit carbon into the atmosphere. And those will never run out. So we're talking wind, hydroelectric, biomass, geothermal, and solar. And those are the big five and give us plenty to work with on the design side for certain when we're designing buildings. So some of these, solar energy in particular, are pretty straightforward to implement on an on-site renewable plan in which we generate their own energy. And that's very exciting. Similar to the idea of an on-site water collection and reuse, capturing and storing energy on site is a great way to lower costs, avoid dirty energy sources, as we all do, and dial up the resiliency of any building. So that's because we're not relying on the grid, and we won't succumb to citywide power outages and other issues water might have. So the goal for every project should be renewable energy production on site. So Ian, most builders assume you estimate how much energy they'll be using annually and then build out with solar panels. Is that all there is to it?
Not quite. There's some pretty cool companies out there that are working right now on how to capture solar energy with windows, with cladding, with roof tiles. I even read an article recently about solar roads. But in order to do our job right as designers and energy consultants, the solar array and the size of the solar array is actually one of the last things that we'll be talking about when it comes to our building design. We're way more focused on energy reduction of the building than the creation of energy, at least in the beginning of the process, because it's easier. It may not sound that way at first glance, but figuring out how to reduce our energy loads using the passive strategies that we've previously discussed in our site analysis and architecture episodes, that's going to be our first step towards sustainability. Take a listen to those if you haven't already. So, Ginger, after we've figured out what on-site assets we can passively use to help our cause, like window shading, daylighting, thermal mass, building orientation, what comes next when we're designing an ultra-efficient building?
Well, we've talked before about some of the differences between analyzing a site for renovation versus new construction, and the energy reduction strategies for each of those differs as well.
That's right.
But there are strategies we can use that apply to both types of buildings. First, the lighting seems like an easy fix right there. LED lighting is now assumed for new construction. It's coming online, and it's also one of the easiest ways to reduce energy consumption in existing buildings by swapping out inefficient bulbs. So often there are power company incentives and grants to help pay for that switch, which is great. So a simple second strategy is installing Energy Star certified appliances such as dishwashers, refrigerators, air source heat pumps, electric water heaters, which can greatly reduce the amount of energy consumed and save you money.
Love it. We talked last episode about the EPA's WaterSense program that certifies water efficient products. And if you want to know more about energy efficient appliances in your home or your building, check out energystar.gov for additional EPA energy information and resources. They're sort of sister programs, I guess you could say. WaterSense for water, and then Energy Star for energy. Here's a fun fact I actually pulled off the energystar.gov site. That if all gas water heaters less than 55 gallons, basically residential, sold in the United States were Energy Star certified electric heat pump water heaters, the energy cost savings would be almost $12 billion each year. 140 billion pounds of annual greenhouse gas emissions would be prevented. And that's actually equivalent to the emissions for more than 13 million vehicles annually.
That is truly astonishing, truly.
Yeah.
And well worth investing in that. So if over half of the average household's annual energy use comes from heating, cooling loads, Just a few $1,000s up front can lead to a huge reduction in energy bills and pay for the upfront cost in just a few short years. So it's really a no-brainer at this point in time. Uh, so Ian, are there any other universal design strategies you think you might be talking about for reducing energy consumption?
One that I like having a conversation about is a tight building envelope. Most green building websites tell you that super insulation and air sealing are essential for a high performance building. And certainly that is true in colder and more humid climate zones, more variable climate zones. But it's not necessarily a one size fits all solution. When your building is airtight and well insulated, one of the things that a lot of people don't account for is how you're going to deliver fresh air to that indoor environment. If it's super tight, then you're not getting as much of those air changes. And otherwise, if you don't account for that, you're breathing in lots of carbon dioxide and VOCs and other forms of contaminated air. So not good. And in certain climate zones like ours here in California, we might actually try to avoid, this is a little out there, but avoid mechanical ventilation and really just focus on those passive strategies. So it might actually lead us to a design that allows for more airflow through the building envelope. So like I said, it's not a one size fits all solution.
Passive heating and cooling strategies here in Southern California. So you make a great point about different climate zones have different creative energy solutions. So always keep that in mind. But for the majority of climate zones in the US and around the world, an airtight envelope is the best strategy for reducing energy consumption and greenhouse gas emissions, right?
Yeah, I agree. It's a really good solution for renovation of older buildings with lots of leaky walls.
Let's keep in mind that air doesn't just leak through the walls. Thermal bypass is defined as the movement of heat around or through insulation, but we don't want to forget about the other air barriers as well. So if your goal is to super insulate the envelope, you have to consider windows and doors as well.
Mhm.
There are lots of moving parts when it comes to sustainable design, which makes it a little bit difficult on the front end. So having a project team that includes energy experts early on is a must. So if you're going to be shooting for high performance and energy efficiency, that's a must to have your team on board early on. So it's very important to then communicate these goals, of course, to your contractor and other folks on the team. And because avoiding thermal bypass is only possible by coordinating and communicating with the different trades before and throughout the installation process and supervising that process to make sure it's done adequately. So take a listen to our Design Charrette episode on how to get everybody to the table right at the beginning.
Communication is key. I'm glad you brought that up, Ginger. You mentioned one of the biggest issues that contributes to poor insulation and leaky buildings is actually improperly installed insulation and air barriers.
Mm-hmm.
It has to be done right every time, each and every time, each and every door, each and every window. So you need to develop some sort of in-house or project-specific procedures for ensuring that consistency, unless you're already enrolled in a certification program like LEED or Energy Star that actually requires that accountability and has somebody to check up on you for that.
Absolutely right. So how would your average design professional even know when and how to consider a leaky envelope as an option for sustainability?
Yeah. A sustainable architect, designer, or consultant really has two things on the competition. They have an ear to the ground when it comes to creative solutions for these common energy problems. And they have energy modeling software, which is very helpful. And
Mm-hmm.
we've talked before about the efficiency requirements here in California for new residential construction, Title 24, as it were. But there are also requirements for commercial and industrial buildings to report their annual energy usage. So many of these folks are now looking for ways to be more efficient. And both of these require energy modeling software that's available to architects, to energy modelers, home energy raters. Those are the folks I'm talking about with those certification programs. And I'm pretty confident in saying that those last two careers are going to grow exponentially as other states, take California's lead and start mandating additional requirements for all these types of buildings. What other energy? And that's exciting. That's exciting.
It is, absolutely.
That
I'm
space is
very
growing.
confident. It's going to grow.
What other energy reduction strategies do we have left to talk about, Ginger?
Well, we'll do a deep dive into the building automation a little bit later in the
Mm-hmm.
series, but having energy monitoring devices or systems in the building that can give you feedback on ongoing energy usage might be just one of the most important energy reduction strategies out there right now. And the only true way to ensure that the use of any building matches the intent of the design is to define that sustainable energy mandate from the very beginning of the project so everyone understands.
Mm-hmm.
We've talked to a lot of folks who design net zero buildings only to discover a year or two down the line that building unit users or the homeowners are still using more energy than they were producing, which defeats the purpose of all the work that went into that design. So overall energy usage of the building over time should be clear, measurable, and make sure everybody's on the same page.
Yeah. We're all familiar at this point with the Internet of Things and the devices out there that can help us track usage in a single family home situation. But I wanted to also throw out there that at the last commercial real estate conference that we attended here in LA, there were vendors from a number of different energy monitoring systems, specifically for multifamily, for commercial office, even entire real estate portfolios. So it definitely appears that this energy cost efficiency idea is going more mainstream for commercial building owners, investors as well. And the good news is that anytime that happens, we're looking at more scaling and we're looking at more adoption across the industry. Okay, let's recap. We've got LED lighting, we've got Energy Star systems and appliances, we got energy modeling during design, energy monitoring as our best strategies. Are we missing anything?
Not many people realize that electricity can actually cost more depending on the time of day that you use it. So there's an easy energy saving solution. The worst time to be running your dishwasher is during what we call peak load hours. For California and most other states, this is generally considered afternoon until about 9 p.m. So if you switch to washing your dishes, doing laundry late at night or early in the morning, you're actually saving money on energy costs.
Free advice right there, folks. And if you're generating your own solar energy and storing it to run your appliances, then you'd actually be avoiding that peak situation entirely. Part of the reason that we're so intent as a company on talking about all electric construction, we keep bringing it up, is that it allows you to design as efficiently as possible because those appliances are going to be the most efficient. Energy Star says so. And you also are able to then use a single clean energy source to power that entire building.
Mm-hmm. We mentioned this before, but the city of Berkeley recently passed legislation to require all electric new construction. And that certainly is the trend in the state of California, which is ahead of the curve on a lot of these things. UCLA as an institute decided to follow suit as well. So we're seeing state, local governments and to really follow suit on the all electric. So it's growing. It's a growing mandate. We support all electric construction wholeheartedly because it has the potential to be 100% renewable energy usage. That's really exciting to me.
Yeah, those Berkeley cats are ahead of the curve.
They got it down.
Hey, did you know that there's actually such a thing as a net positive energy building these days? Ginger, what happens to the extra electricity that isn't immediately used in a situation like that?
Oh, great question. There's actually two options that can be combined to offer solutions for every energy resiliency issue manageable. So the first is battery storage. So maybe you've seen the Tesla Powerwall battery that can be installed to store energy from the building's solar system and hang on to that energy for a backup. And it helps out during those long stretches of consecutive cloudy days like we've had here in Southern California in the last couple of weeks without tapping into the grid. So you have your own energy source stored wherever that Tesla battery is. The second option is net metering, which allows individual homes and building owners to essentially sell their excess energy back to the grid or to the neighbors, to the neighborhood grid. So here in California, the electric company actually gives us an additional bulk discount on electricity for anyone who's a net producer of electricity rather than a consumer. So you it pays for them.
Yeah,
Yeah, it pays for them. So
that's awesome.
we at Sustainable Homes of the Future support a nationwide energy grid at the federal level, and that's coming down the pike, being talked about politically. That supports renewable energy production throughout the United States interconnectedly. So it may take some time, but we can do it with a mandate from the feds and people like us shouting out and making our voices heard.
Yeah, we're really, we're hopeful that these kind of incentives will eventually catch on with a larger section of the population. But, sometimes it does take regulating against things alongside those incentives to motivate some of those stragglers to change. Sad, but true. Just a
Mhm.
reminder, everybody, uh, before we wrap up here, there are plenty of ideas that we didn't have time to touch on today. We're trying to keep this around 20 to 25 minutes, like using the ground to heat and cool the building, geothermal or solar water heaters. But both of those systems are bigger upfront costs compared to the strategies that we share today. So we're choosing to focus on the low hanging fruit here in season 1 of the podcast.
So stay tuned as we transition from season 1 overview to more specific deep dives of those subjects Ian just mentioned in season 2 and beyond, and plenty more. So, and be sure to listen to Ian's interviews with our other green building professionals in the areas of real estate, construction, and design. So very interesting conversations.
Thanks for the plug. Yeah, it's been super fun talking to all my guests, and I always learn something. I always learn some new idea or innovation. It's actually one of the questions I like to ask at the end is, what's the most exciting new, material or method or process, that you've discovered in the last few years, and there's some really cool ones out there. And I think that wraps it up for today's episode. Leave us comments, please, about what you heard today. Don't forget to subscribe or follow the podcast. Obviously, the more followers and subscribers and comments and things, the more engagement we have with the podcast, the better.
Mm-hmm. And just for a sneak preview, you mentioned materials, where our next episode will be all about sustainable green building materials. So that's going to be really fun and exciting. Feel free to reach out to info@shfbuild.com with questions, comments, or suggestions of further topics to explore, and when it comes to best practices in the green building and sustainable design arena. So
yeah, please tell your friends about the podcast, share the link, contribute, as I said, follow us, or just listen, whatever you feel inclined to do. Thank you, Ginger. This has been another great chat for sure.
my pleasure, Ian. Thank you, listeners, for tuning into our podcast.
Yes, thank you, fellow green building enthusiasts, for listening to the Building the Future podcast. Just to sum up today's episode, solar panels, other forms of capturing renewable energy, they're great tools once you've designed your building to be as energy efficient as possible, using passive strategies, proper insulation, efficient systems and appliances. But you have to do the work on the front end. You can't just slap solar panels on the top of the building and call it green. It's not. So until next time, lead with efficiency, harness the power of clean, renewable energy, and you can achieve net zero energy or net zero carbon in your next building design. Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future.